Okay, so we're going to be introduced to geometry today. And the very first thing we need to know about geometry is that it's about the real world of shapes, distances, measurements. And so I wanted to start us off with a very concrete, real world example of something that may happen to you in your life that it's hopefully relevant to you, okay? Uh, so let's say that you're a plumber. Yeah. And you're installing a drain that's going to go from a sink down to the main drain. Okay. So that's plausible that you might have to do that someday, especially if you end up being a plumber. Now, let's give some context to this picture here. Let's say that this is the wall, and this is the floor. So we're thinking about like a house, okay? So you got the sink, maybe it runs underneath the cabinet, and down here there's a little hole for the drain, and you're a plumber, you're working for a master plumber, your master plumber comes to you and says, I want you to go cut me a piece of pipe that is the distance from the sink to the drain. And you ask the master plumber, you say, okay, how long do you want me to cut the pipe? And he says, figure it out. Okay. And then you say, okay, how far is the drain away from the wall? And he says, the drain is 1 foot away from the wall. Okay. And you say, how high is the drain off the floor? And he says, the drain is 2 feet off the floor. So 1, 2. And then you say, okay, how far away from the wall is the sink? And the master plumber says, it's 4 feet away from the wall. And you say, how high is it above the floor? And he says, well, it's 5 feet above the floor. And you say, okay, now what? And the master plumber tells you, figure it out. Right? So let's assume for the moment that for whatever reason, you can't just go in and directly measure it, all right? You can't go in with the measuring tape and just measure it off. You've got to figure it out from this information. This is enough information for you to figure out how long to cut that pipe. So let's take our straight edge and draw a line connecting these two dots so we understand like what we're trying to figure out here. We want to know this distance. There is something called the distance formula that will teach you or show you how to find the distance between 2 points. So we're going to learn here the distance formula. And we usually label that D for distance. D is equal to the square root, and now I'm going to say it out loud because I want you to hear this. It's the square root of the sum of the squared differences of the x and y values. Okay, so what that looks like written down is the square root of the sum, okay, of the squared differences of the x and y values. There. That's the formula. It looks complicated, so I want to make sure that by the end of today, you can create this formula even if you can't remember it. But for now, let's just write it down and let's plug in our numbers and see what we get. Okay. So it goes without saying that we need to label our points. We can label this here x1, y1, x2, y2. So suddenly we're thinking about the location of the drain and the sink as coordinates, right? And this kind of is like a y-axis and this is like an x-axis, right? So let's plug in the numbers and see what we get. So this is our pipe. This is the length of the pipe. It's going to be equal to the square root of, open parentheses. Now x2 is 4 minus x1, which is 1. That's going to be squared minus y2, which is 5, minus y1, which is 2. That's going to be squared. This is a plus symbol right here. And we're taking the square root. Okay. So we're just going to keep working it out.
So first is plus now is minus. Oh.
Yeah, so there is a plus sign in between the parentheses, but then inside the parentheses you're subtracting. Okay. So we got the square root of, now 4 minus 1 is 3, so that's 3 squared, plus 5 minus 2 is 3, so that's 3 squared. So it's the square root of the sum of 3 squared plus 3 squared. Okay. Well, 3 squared is 3 times 3. 3 times 3 is 9. So the distance of the pipe there, the length of the pipe is going to be the square root of 9 plus 9. So the distance of the pipe is going to be the square root of 18. We all know square roots can come in plus and minus form, but in geometry, we're typically only concerned with the positive root. Okay, so at this point, it's helpful, since we don't know what the square root of 18 is. This is what I would do if I was on the job site. I would say, hey Siri, what is the square root of 18?
The square root of 18 is approximately 4.24264.
So approximately 4.2464 feet. Do you see this little apostrophe thing I put at the end? That means feet. Okay, 2 of them means inches, but 1 of them means feet. So instead of writing FT for feet, we can just put that. You understand? Okay. Now, nobody's going to measure off that many decimal places. So in construction, why don't we round to the 10th place? So it's just 4.2 feet. That's the distance here. So you go cut this pipe and you bring it back to your boss and you show him this math, and your boss says, go ahead and please place that pipe on the floor and go get out of those dirty clothes. I want you to go into the office, get some air conditioning, get you a cup of coffee, because if you can do this kind of math, then you can put your hammer down and pick up the drafting pencil and go work on the paperwork. See what I'm saying? Yes. You use your brain. You got muscles, right? You got these muscles here, but then you got a big muscle up in your head, and you get to choose which one you use. But because this muscle needs to be cooled down a lot in order to work properly, if you want to use this muscle, they put you inside with the air conditioning. So the little trailer that's parked out in front of all the construction sites, that's where you want to be. All right. So pay attention here, because this is real world math. Now, I want to show you what's going on. And I told you this formula kind of appears out of nowhere and it kind of looks confusing. So let's take a look at what we've got here. And if you'll just allow me for a moment, I'm going to erase some of this stuff so I can show you something. So we get rid of all this. Get rid of this. Okay. Take your straight edge and draw a horizontal dotted line or dashed line like this. And then take your straight edge and drop down a vertical line here until they meet. And then in the crevice there, put you a little square to indicate that that's a right angle. Now suddenly we're not dealing with the drain anymore. We're dealing with the triangle. And we're going to label this bottom piece here A. And we're going to label this height here B. And do we remember the H word? That means this long side here. Hypotenuse, hippopotamus. Okay, and we're going to label that C.
That's a false name.
Okay, yeah. So, does anybody remember the Pythagorean theorem? The Pythagorean theorem? Close. You got all the letters.
A squared plus B squared.
Okay, Pythagorean theorem. Pythagorean theorem states that a squared plus b squared equals c squared. So if I want c by itself, I got to take the square root of both sides. Like that. And if you'll allow me to move the c up front, then we get c equals the square root of a squared plus b squared. Now you should notice this is already starting to look like this. Okay? So now you're saying, but wait a minute, bro. Where's this x2, x1, y2, y1? Well, you tell me, look, the a value is the total distance from here to here. Okay? So that means it's the distance between this 1 and this 4. Okay? Well, what's that distance? 4 minus 1, right? So there it is, 4 minus 1. It's the difference in the x values. Okay? And then b squared, well, that's the height. So you'd want to look at the y value, the height value, and that's 5 minus 2. Here it is, 5 minus 2. So if you ever need to reconstruct the distance formula, you always can do it. Now you understand where it comes from. It's not just a formula that's pulled out of thin air. Okay, there it is. Okay, now we're going to switch gears a little bit, and we're going to do the fun part of geometry, which is drawing. So for that, I'm going to need to pass out some different paper. Plus,
You're still gonna need a straight line?
yeah. I need everybody to take 2 sheets of paper. You got to have 2 sheets. You don't need 3 or 12. You need more than 1. Okay. Yeah. Take 2 sheets of paper, pass it around, please. And each of you will need one of these deadly weapons /
Compass.
navigational instruments / geometer's tool, and somebody correctly identified it as a compass. All right. So I'm going to walk around and let you borrow one of these. Now, please be advised, these do not belong to Westwood High School. These belong to me.
So you bought one?
Yes. Okay. They're very delicate and they're very expensive. These are the good ones.
Also very sharp.
I need you to stack the pages one on top of the other. The bottom sheet is going to serve as a cushion for the top sheet.
Why?
Before you use the compass, don't draw it or anything with it. Before you use the compass, I need to talk to you about compass use, compass preparation, and compass safety. Well, one of your parents in the armed forces? Usually that the USAA has got a lot of benefits. Veterans. Yes. Okay, now let's talk about this device. And for me to do this talk, I need to zoom this camera in to what could possibly be a cringeworthy and uncomfortable distance. But I'll try to keep my face out of it. There we go. All right, so this is the compass. Now, do you see this little end right here? That's where you hold the compass. Okay. Now, do not do this. All right, so it's a very delicate instrument. Do you see this threaded screw right here? So do not pull the compass apart like this. Don't do that. Instead, turn the wheel. That's why there's a wheel there. It'll change the compass width. Okay, that's how you do it. So don't ratchet it back and forth like that. Otherwise, you'll strip out that screw. Now we need to talk about the compass and all these little dials. So these are tightening screws. And sometimes when you get a compass, one of the screws has come loose and you might have the arm bent. So just snap that sucker back into place and tighten it down. Go ahead and just give each screw a quick turn. And if it's already tight, don't ratchet it down too much. Just tighten it to the point where it's kind of resisting your turn, okay? But we're not trying to ram it until it's tight. Okay, now, if you put the compass together like this, the tip of the pencil should be flush with the tip of the point. You see here, this compass isn't. Not only is this compass not flush with the tip, but it's dull on the pencil side. So I need to unscrew this blue dial here and remove the pencil for just a second and sharpen it up. Okay, so now I've sharpened up the pencil, and now I need to adjust it so that when I put the tip together with the pointy end of the compass, they're flush. So you want to manipulate that pencil just up and down until it's flush with the tip of the compass. Okay, just kind of have to mess with it for a minute. Okay, I'll pass around a razor blade. Sharpen up the pencil more. Okay, now look. I want all of you to try, while the sharpener is going around the room, I want the rest of you to kind of open up the compass a little bit, maybe approximately the distance from the tip of your index finger till the middle knuckle, like that. Try to draw circle, okay? Now I want to give you a hint. Most people need some help learning to do this. So if it's difficult at first, I'm going to walk around and show each one of you exactly how I want you to do it. Okay? So the way that you do it is you plant the pointy end into the paper. Don't dig down until you're pressing into the desk. Just dig it into the paper and then let gravity kind of bend your hand and you angle the compass and you just turn the knob, okay? Alex has got the process down. Can you lay your clipboard there for me?
Anybody else need to?
You're gonna plant that needle point in there and then just turn the compass.
Yes, I do.
I'm going around to show you what I want you to do. Plant the point.
It's a very scary experience. I feel like
Anybody see that sharpener? Good, you got it.
Whoa, this is weird.
Plant the point.
I feel like it's gonna lift off the paper and it's like shoot.
Why
Why do you feel that's gonna happen? See, it did it right there. I did.
It should be one fluid motion. All right, let me show you. You're not supposed to turn the page. So assume that the page is kind of fixed in place. Plant the point. And rotate. See how I'm at an angle? You want to be at an angle. Plant the point. Rotate a circle.
I can have
At an
that.
angle.
I feel like I'm just like.
You're getting good. Okay. Try to angle your hand over, just like that.
Yes,
Let me show you.
sir.
You pretty much got it. You need to open the compass up a little bit and then angle like this. See, it's almost like you're in a little dance. Just give it more of an angle almost. Most people are drawing their lines they're pressing too hard with the lead. You kind of want to let the gravity do the drawing for you. I'm gonna plant the point. Rotate it and angle.
Oh.
Plant the point. Rotate and angle.
See, I did it right there.
Very nice, very nice. Very good. Good. This is a technique. It's kind of like learning how to properly knead dough to make bread, or it takes a certain amount of practice. So don't feel too bad. I'm sure some of our very good sports players in the room, there was a time when you had never held a football or softball before, or volleyball. And so don't feel bad. I mean, if this is kind of your first exposure. Okay, now, once we're done playing games there, let's turn the page over so we're on a fresh, blank sheet of paper. Now I want to show you something really cool. Okay. Look up here at the board. We want to close the diameter of the compass slightly, maybe to be a little less than the distance from the tip of your finger to the knuckle. Now it's very important. We're going to draw 4 circles, okay? You cannot change the diameter of the compass as you do this. This is the reason I invested in the good ones for you. So if you don't mess with it, it will stay the same diameter. So what you're going to do is up at the top middle of your page, what you're going to do is plant that compass. Now check to make sure you're not going to draw off the top of the page. Just check. Once you plant the compass, rotate a circle. Okay, we want to keep these circles light because we're actually not going to, we're going to use the circles to do something, but we're not actually going to do anything with the circles. Now, if you've lifted your compass off the page like I have, go back and find the little center hole and put it back there. And then take your compass and come down here on the bottom and kind of move back and forth with the lead until you darken one little part of it like that. You see how I've got that little mark? Now take the pointy end of your compass and put it on the perimeter of the circle right there on that mark that you made, and draw another circle. And this circle should pass right through the center of the circle you just drew. Okay? Now you form something called a vesica Pisces, mostly because this is like the fin or tail of a fish, and then this forms the fish head right here. All right, now we're going to draw two more circles. We're going to plant the tip of our compass right there and draw a circle, and then we're going to plant the tip of our compass right there and draw a circle.
Where they connect?
Where they connect. Be real precise with this, okay? Get that tip planted, draw a circle. It's the same. I messed it up because I'm trying to draw vertically. It's the same diameter as the other circles, okay? And then you come over here and you draw another circle. Don't recommend doing this vertically. And if you did everything right, you'll notice several points intersect. Okay? Take your time. Now, if you have a pencil or a pen, it helps this next part. We're going to make some little marks. All right? Remember, the point wasn't the circles. The circles are going to be used. So now what I want you to do, you see where all these lines intersect right here? It's right at the center of your original circle, right there. All those lines intersect, put a dot right there. Okay? It's at the very center of your original circle. Now, down here in the bottom left and bottom right, where these two outer circles intersect down here, put a dot here and a dot here. And now we need to take that credit card or that student ID, and we need to connect the dots.
Should be the perfect time. No.
Okay. If you did everything right, this is what you should see. A perfect equilateral equiangular triangle. That means that all sides and all angles are equal. Okay?
I tried to do some of these.
I'm coming around to see. Good job.
Oh, yeah.
Okay. No. Good job, good job. Good job. Can I have my credit cards back? Can you borrow the credit card from me?
I'm slanted, listen,
No, it's okay. You still haven't got it yet. Okay, real quick, let's review what we learned today. Today we learned
How they find it.
how to find the distance between 2 points using the distance formula. D equals the square root of the sum of the squared differences of the x and y values. We did an example, real world example of a pipe from a sink to a drain. And then we derived the distance formula by starting with the Pythagorean theorem, a squared plus b squared equals c squared, solving for c. And we learned how a and b are really just those x2, x1, y2, y1. Then we took a compass, we learned what that was all about, and we drew some circles, and we came up with this special triangle. Okay. Geometry should be a drawing activity. Okay. I think too often geometry is taught as a very, very boring list of theorems and postulates, and we lose sight of the fact that it's all about the more art, the artistic thing. So if you took your time with this drawing, you should have something that is artistic in sort of a precise geometric sense of the word artistic. So I really hope that you learned something today. And we'll kind of pick this up tomorrow.